A simple way to analyze risk is by calculating estimated monetary value, or EMV, and using a diagramming technique called a decision tree. Here we have a sample problem from Kathy Schwab for our consideration. There are 4 projects listed here with a variety of potential payoffs and losses. We will be performing the calculation for EMV for each project and then creating a decision tree based on these probabilities and the estimated monetary values arrived at from them. The calculation here is pretty straightforward. We are using the probability percentage as a decimal and multiplying that by the estimated gain or loss, and then adding up all the possibilities to get our EMV for that project. So for project 1, 50% is represented as 0.5. We multiply that by 120,000 and add that to our other 0.5 chance at a loss of negative 50,000, which results in 60,000 minus 25,000. And the final EMV for project 1 is then $35,000. Project 2 has 3 situations to calculate for. 100,000 at 0.3 or a 30% chance, plus 50,000 at 0.4, plus negative 60,000 at 0.3, with a result of 32,000. Next, we have project 3 with a really high probability of a lower profit. 0.7 times 20,000 added to a possible loss of 5,000 at 0.3, giving us an EMV of 12,500. Finally, project 4 also has a 70% chance for a positive return, spread out a bit more as far as the amount of profits and a larger possible loss than project 3. This is our longest calculation with 4 separate scenarios represented, which give us an EMV of $15,000. This table has all the components of a decision tree. The layout is just different. This is a typical representation of a decision tree. Now that we have this useful visual and the completed EMV calculations for each project, we can start comparing the possibilities. I'll discuss my evaluation, but keep in mind that depending on your own risk tolerance, you may reach a different conclusion. For my first choice, I would select Project 4 because it has the least potential at 20% for a loss and an 80% potential to return $20,000 or more. This attitude would be risk averse, as I'm interested in the option with the least likelihood of loss rather than the best opportunity for a larger payoff. While Project 1 has the greatest opportunity for payoff, it also has the greatest potential for the second highest possible loss, a 50% chance of losing $50,000. Project 2 also has a high potential payoff with a good likelihood at 70% of a good payoff, but it also has the greatest loss amount at $60,000. Project 2 would be a hard option to pass up with its high likelihood of profit and the great potential payoff, so it would be my second choice. Project 3 doesn't seem a very good choice at all, especially when compared with Project 4. Project 3's potential payoff is fairly solid, but for the 70% certainty, there is very little profit.